Hello students, my name is Shashank Shekhar. So today we will start the new chapter, that is Haloalkane and Haloarene. So the chapter that we are going to study has this syllabus. So if you look at the syllabus here, so we have to study with the nomenclature, the nature of CX bond and the reactions associated to it. Similarly for haloarenes, we have to again study the CX bond nature and the reaction and their preparation. So let us start our today's class. So today I will be not going to this nomenclature part. Instead of that, I will be giving a brief introduction of what is haloalkane and haloarene, and we will also see the classification. Now you would ask that why the classification is important. See, because sometimes the nomenclature are associated with our this classification, like it is written benzylic chloride. So that thing is based on classification. Or sometimes in the question you are asked like directly you are not asked that which one of this is a vinylic. So, such a direct question is not expected, but it is written like you have to say identify a compound. Many times question are asked, the reactions related to that compound is given, and you have said that okay, identify the compound. Now the question statement would start like this, that a vinylic haloalkane does this. So give the structure of this compound or say what is the molecular formula of this compound. Now if you are not aware about that what is vinylic alcohol or vinylic haloalkane or haloarene, then you will have a back foot. Then you will find it difficult to find it or identify that compound, and missing one information is would cost you a lot. Okay, so you should be aware about it, that what is vinylic, what is allylic, what is benzylic, what is this alkyl. So let us start our today's class. So if I look at the topics of today's class, so I will give you the introduction of this haloalkane and haloarene. Then we will see the classification. On what basis we can see the classification. We will see on the basis of number of halogen atoms. Okay. Then we will see this compound containing sp3 and compound containing sp2 CX bond. Okay. So first of all, what is haloalkane and haloarene? So for that, you should know what are halogens. So you must have studied this S and P block, main group elements, and you have heard the term halogen there. So they are basically the group 17 elements which are having 7 electrons in their outermost shell. These compounds are fluorine, chlorine, bromine and iodine. Now what do? Is we replace, suppose we take a compound, say we take a methane, then we have 4 hydrogen attached to 1 carbon. Then what do? We replace one of the hydrogen with a halogen. That halogen can be anything: chlorine, bromine, iodine, fluorine, any 4 of this. Now the resultant compound we got after replacing it with a halogen is termed as haloalkane or haloarene, depending upon the structure that we have. If it is an alkyl halide, so we say if we have suppose a linear chain, then we tell it as haloalkane, and if it is connected to an aryl compound, then we call it as haloaryl or haloarene. So it is written here also, the replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon, both. So if it is replaced in aliphatic, we term it as haloalkane, and if it is replaced in aromatic, then it is termed as aryl halide. Aliphatic, like we have this methane, ethane, propane. So we can have methane. Let me write it here. We can have methane, ethane, propane, and for aromatic we can have benzene, or we can have this, say, tropylium ion, or instead we can have furan also. So furan looks like this. It is also an aromatic compound, heterocyclic aromatic compound. You must have heard this word if you have studied this biomolecule. I think it is later on in this class 12 only. So you will study there the furan structure. Whatever. Now If we replace the hydrogen in such compounds in aliphatic or aromatic, we get the resultant compound as alkyl halide if we have the aliphatic chain, and aryl halide or haloarine if we have aromatic one. Okay. The haloalkane containing compound are attached to sp3 carbon, whereas the haloarine containing halogen atoms are attached to sp2 hybridized carbon. Okay, so this is not true always. We will see examples of haloalkane. So this is haloalkane, yeah. So if the halogen is attached to a carbon that is sp3 hybridized, we term it as haloalkane. And if it is attached to a sp2 carbon of an aryl group, not any sp2 carbon, but the carbon which is of aryl group, then we call it as haloarine. Suppose what will happen if we take an example of ethene and replace one hydrogen with halogen. So I mean here that we take ethene and what we do, suppose we replace this one with one halogen. Say we are replacing it with chlorine. Then the resultant compound would be this. So this hydrogen has been replaced by chlorine. Now what will we say it? So I have told you that if the carbon is sp3 hybridized and we replace a hydrogen, then we say it as haloalkane. So this will be termed as haloalkene. Okay, haloalkene. Clear? Okay. Now, next. Now, what is this benefit of studying this haloalkane or haloarine? So they found a very wide application in the pharmaceutical industry. Okay, so they are clinically very useful. Like the chlorine containing compound are used as antibiotic or chloramphenicol, or say these are produced by microorganism, is very efficient for the treatment of typhoid fever. So this chloramphenicol, it is produced by microorganism. It is a compound that is containing chlorine. So it will be haloalkane only or haloarine depending upon the structure. And it is very effective for the treatment of typhoid fever. So they are clinically useful. Also, we need iodine containing hormones like thyroxine, the deficiency of which causes a disease called goiter. So you must have heard this term goiter, in which you were told that, okay, so if you take salt, or you can say iodine containing salt in less amount, then this would lead to a medical condition termed as goiter, in which your area below your neck, it gets swollen. So it basically happens due to deficiency of this iodine. Now this iodine is produced, our body produced iodine containing high hormone, that is thyroxine, and this helps in acting as a medicate for goiter. Okay. Now synthetic halogen compound like our chloroquinone, so this was not the synthetic one but the naturally occurring, that is chloraminophenol or this thyroxine, these are naturally occurring. If we talk about the synthetically organized, or you can say synthetically manufactured chlorine compound like chloroquine, it is used for the treatment of malaria. Or haloethane is used as an anesthetic during surgery. Anesthetic, you know it. What is anesthetic? First of all, what is the haloethane that is used? The chloroform. So the chloroform is used to make people unconscious, or you can say numb, some parts of the body numb, so that surgery or any operation can be performed. Nowadays, this chloroform is not in use because it has some side effects, but they were used earlier. You must have seen that in movies and all, that while someone is kidnapping someone, they put this chloroform. They say also that we have put chloroform on your say your handkerchief, and they try to just make the required person unconscious and then kidnap him or capture him. So that compound is also an example of your haloalkane. Its formula is CHCl3. Certainly, fluorinated compound are being considered as potential blood substitutes in surgery. So they can be used as potential blood substitutes. Blood substitute means in place of blood, we can use this fluorinated compound. So you can see that what a wide application this haloalkane or haloarene has on our daily life. So I think they are mainly used in our clinical methodologies and for our medical purposes. Okay. Now let us move to the classification of this haloalkane and haloarene. So we will classify both haloalkane and haloarene today. So if we look at the classification, so if the number of the compound is taken as the basis, so it can be classified on 3 bases basically. So if it is classified on it can be classified on the number of halogen compound. Say we have 1 chlorine attached, 2 chlorine attached, 3 chlorine attached. So all will result in a different halogen compound. Then we have this compound containing sp3 CX bond. sp3 or the CX bond. So basically we are talking about the haloalkane. Then we will see the classification in that. Then next we will see the compound containing sp2 carbon. Compound containing sp2 CX bond. So here X is chlorine, fluorine, bromine, iodine. Okay, so one thing more I have to mention here is that, so you will often see that haloalkane compound are compound that are usually shown by the letter X along with the compound that you're dealing with. So this X represent the haloalkane and haloarene. In general, I am saying that you will if you read a book or something like that, you will see that okay, CH3X or C2H5X, so something like that is used. So do not get confused that X is nothing but any of the halogen that you think of, fluorine, chlorine, bromine and iodine, until and unless it is not mentioned. So in some cases it can be mentioned that okay, X can be only chlorine or X can be only chlorine, bromine, fluorine, iodine, anything. Okay, like here all of these are mentioned. So since it is the first time for you seeing this X, so I mentioned what is X. But in a book, if you will read, this will be not mentioned. So you have to assume this is any of this halogen compound. And if it is not mentioned that which halogen compound it is, then you can take any of these. Now we'll try to classify the halogen first on the basis of number of halogen atoms. Okay, number of halogen atoms. So based on the number of halogen atoms, we use the suffix that is mono, di, tri. The mono for single halogen atom, di for 2 halogen atom, and tri for 3 halogen atom. So we can have both haloalkane and haloarene as the example. So first is this upper part has the example of this haloalkane. So here one X is attached. So one X is attached. Therefore, it is termed as monohaloalkane. It is haloalkane because the X is attached to a sp3 hybridized carbon. Structure will look like this. Okay. So this will be our C2H5X. Now this X can be chlorine, fluorine, bromine or iodine. Clear? Next we can have the example of dihaloalkane. Dihaloalkane means 2 halogens are present. So you can see 2 halogens are present. Now you can see that in each of these examples, we have used the term X. Now I have told you earlier, this X will denote any of the halogen that you think of. So do not get confused with this X. So this is example of dihaloalkane in which we have two halogens X and X. Again we have trihaloalkane which has 3X. Now in all of these three compounds, the carbon is sp3 hybridized because here you can see it is forming 4 bonds. Here this carbon is this one. Here also it will look like this. So the second carbon will be here. Okay, this one also. So you can see that haloalkane can be of 3 types, that is mono, di and tri. They can be further classified as tetra, penta, pentahaloalkane or something like that. So this is the classification which is based on the number of halogen atoms. Now if we consider the haloarene, so sorry for writing not writing here haloarene, so putting a haloarene here. So we can have both. Suppose we take a haloarene. So this is the haloarene. How? We can see very clearly that we have a benzene ring, and suppose this is our benzene ring. Now we will have a hydrogen at each carbon to complete the valence A. Now what we have done in this compound, we have replaced one of the H by X. So we got this. So it is an example of haloarene. Now since one of the hydrogen is replaced, then we call it as monohaloarene. Now if two hydrogens are replaced, as in this case, like if we replace this one also, then it will be termed as dihaloarene. And if we replace 3 of them, then we term it as trihaloarene. Is clear? Okay. Now each of this compound is a derivative of our normal alkane and alkene only, or normal alkane and arene only. We have just replaced one H by one X. Okay, so in this 1 H is removed, in this 2 H is removed, in this 3 is removed. Similarly in haloarene, 1 H is removed, 2 H is removed and 3 H is removed. And we got the classification of this haloalkane and haloarene based on the number of halogen atoms we have. So for monohaloalkane we will have 1 halogen. For dihaloalkane we will have 2 halogen. And for tri we will have 3 halogen. Similarly for monohaloarene we will have 1 halogen, 2 halogen and 3 halogen. So this is the classification based on the number of halogen atoms that a compound have. Now next we have the alkyl halide or haloalkane. So here we are classifying it on a different basis. Okay. So let us start this classification. So in alkyl halide, the halogen atom is bonded to an alkyl group. So the homologous series would look like this. You must have seen this series earlier also, but the formula was changed. It was CnH2n plus 2. Now what we have done here is we have replaced one hydrogen. Therefore, the number of hydrogen has been decreased by 1. So the total number of hydrogen is 2. It is decreased by 1. That would give us CnH2n plus 1. Therefore, we got this formula. Okay, which is CnH2n plus 1. And what we have done, we have replaced it with a X. Therefore, we got the formula as, after replacing hydrogen with X, or you can say halogen, this formula changed to Cn H2n plus 1 X. So this is our new formula, and it's a homologous series. So what do you know homologous series? So we keep on starting from n is equals to 1. We can go like this forever. And you also know that carbon has a very good property of catenation. It can form long chain of carbon compound. So we can have the formula like C1. Suppose n is equals to 1. That would give us 2n plus 1 is equals to 2 1 2 plus 1 3. The formula would be CH3X. Similarly, if n is equals to 2, that would give us 2n plus 2 is equals to 5. 2n plus 1 is equals to 5. So we will get it as C2H5X. Again, we can have 3. That would give us 3 plus 1, 7. That would be C3H7X. And n equals to 4. We will get it as 4. This 2n plus 2 value as 9. The formula would be C4H9X. So you can see that we are forming a homologous series which will look like this: CH3X, C2H5X, C3H7X, C4H9X. Okay, this is clear. So this is the homologous series that here it is talking about. Now this homologous series can be further classified into primary, secondary and tertiary based on the number of carbon atoms it is attached to. So we are talking about which carbon? We are talking about that carbon which is attached to halogen. So if that carbon which is attached to halogen is attached to a single carbon, then it is termed as 1 degree haloalkane or primary haloalkane, primary alkyl halide or 1 degree alkyl halide. So we are using the term alkyl halide, no problem. So here we have an example. So suppose this is a homologous, this is a primary carbon. Why? Because this carbon is attached to only one carbon. So I've seen an example right now here also. So if we expand this one, that is C2H5X, that would look like this. It would look like this. So here what we have done, we have replaced one hydrogen with X, and what we got is this carbon is attached to only one carbon and rest of the 3 spaces are occupied by hydrogen and halogen. So this is an example of this primary halogen. Again, we can have secondary. How we can have secondary? So you must have heard this term. This is isopropyl. If we attach it here, then we will call it as isopropyl alkane, isopropyl haloalkane. So this is an example of 2 degree. Again, we attach one more carbon, that is 3 carbon in total, then we will get it as 3 degree. Remember this thing, that this R dash and R triple dash, all of this must have carbon in the starting. Okay, they should look like this. Now further we have kind of group. Okay, this R dash, R double dash and R triple dash can be same or different, no problem. It will still be a tertiary haloalkane or secondary haloalkane. So here we example of a secondary haloalkane. So example of generalization you can say, and here is a generalization of tertiary haloalkane. Now one more thing, what will happen to this? What we will call this one? So this one we also as termed as primary only. There is nothing like 0. Okay, so this will be also put under primary haloalkane. So we have primary, secondary, and tertiary. This is the first basis of classification, in which we classified the haloalkane or alkyl halide on the basis of the carbon atoms, the number of carbon atoms the carbon it is attached to. And which carbon is attached? The carbon which is having halogen. So this is clear. Now we'll see other classifications. So this is the compound containing sp3CX bond. Okay, sp3CX bond. And the X here is chlorine, bromine, bromine, and iodine. Again, I am told you earlier also that X is the representation of this halogen. Now, what can be the example of this? Now, if you see here, two types of sp3 carbon containing compounds are possible. The first one we have seen was alkyl. This one is called as allyl, and the second one is called as benzyl. What is the difference between alkyl, allyl, and benzyl? Okay, so in this allyl, if you look that this carbon to which this X is attached is a sp3. For those who do not know about sp3, sp2 or sp, so if the carbon is forming 4 bonds, 4 independent sigma bonds, then we will call it as sp3. Now, if the carbon is making a double bond with someone, single double bond, and remaining 2 are single bonds, then it is called as sp2. And if the carbon is making 3 bonds, only 2 bonds, okay, only 2 bonds, so 2 pi, 1 sigma and 1 sigma, then in that case we termed it as sp carbon. So here what we are telling, that the sp3 carbon to which the halogen is attached, that carbon is attached to a carbon which is sp2 hybridized. So here you can see that this carbon here is sp3, no problem, but this carbon is sp2. Why? Because this carbon has a double bond. So if you expand the structure, it would look like this. So for the beginners, I would suggest that, okay, try to expand the structure so that you can get a much more clearer picture of this. Okay, so make it a practice of expanding for right now. It would be a good thing to do. That would increase your efficiency. You cannot say, you can say accuracy. Okay, so here you can see that this carbon here, it is having a double bond. Now, due to this reason, it is a sp2 hybridized carbon, and such carbons or such haloalkane in which the halogen containing carbon is attached to a sp2 carbon, such carbon is called as allylic halide. Such a halide is called as allylic halide. So what is this term halide here? So this is a you can say a common name. So we can call it haloalkane or alkyl halide. Okay, so do not get confused with it. It is same as this haloalkane only we have just made a further classification it into allylic and benzylic and alkyl halide. Okay, so this is an example of allylic halide in which the carbon which is attached to halogen, the sp3 carbon which is attached to halogen is instead attached to a carbon which is sp2 hybridized. That is forming carbon-carbon double bond. Okay, carbon-carbon double bond. Again, next we have the example of benzylic halide. So if you look here, so do not get confused with it, that why we are not stating this as allylic only. Okay, so if you look at it, you will say at one instance you will say that, okay, this is the carbon, sp3 carbon to which the halogen is attached, and this carbon is instead attached to that carbon which is a sp2 hybridized. But you look here that it is not completely sp2 hybridized, because we have a kind of conjugation here due to benzylic one. So what's the difference between allylic and benzylic is that in this case the sp2 carbon which we are talking about is not a part of an aromatic system, but in this case this sp2 carbon is a part of aromatic system, and such compounds or such halides are called as benzylic halides. What it is called? Benzylic halides. And here, from here only, we will get the nomenclature as benzyl alcohol or benzyl chloride. So I have told you in the starting also that why it is important to study the classification, because sometimes you may be said that okay, a vinyl compound is taken or a benzyl chloride is taken, and in that instance you will get confused that what is this benzyl and what is this aryl. Now what the student make mistake here on identifying benzyl one, they say that okay, this is our benzene. Now if we see this one, then do not tell it as benzylic halide. Why? Because this X is not attached to a carbon, which is this X should not be attached to a carbon that is a part of this aromatic system. So since this is attached directly to the carbon which is a part of aromatic system, therefore we will not term it as benzylic halide. This is not a benzylic halide. This is instead a haloarene. Okay, this is not a haloalkane also, this is a haloarene. We will see the example further, but I am just making a point here that if your X is directly attached to a carbon which is the part of the ring or the aromatic ring, then in that case you will not term it as your benzylic halide. Okay, is this clear? Okay, now we have one more example here. In this case we have this X attached to a carbon and this carbon is attached to a carbon which is a part of the ring. Now what about the carbon that is present here? What type of carbon it is? Primary, secondary, tertiary. So if you look here, this carbon here, it is attached to 1, 2 and 3 carbons, and it is written this R and R dash are suppose CH3. Suppose this R and R dash are CH3. Then in this case, we will call this carbon as 3 degree. Hello? Or 3 degree alkyl halide. This is clear? Okay. Now, next thing, I want to make a point that this is called a 3 degree alkyl halide. Here also, what we will call this one? This will be a 1 degree. It is mentioned also, it is 1 degree. So this is allylic and this is bibenzylic. So in nutshell, I would say that, okay, if the carbon attached to halogen is attached to an sp2 hybridized carbon which is not a part of aromatic ring, then in that case we will term that halide as allylic halide. And if the carbon is a part of this aromatic ring, like this one, in which this carbon is a part of the benzene which is an aromatic system, then we term it as benzylic halides. This is clear? But in both the cases, the halogen is attached to that carbon which is instead attached to a sp2 hybridized carbon. Now let us move to sp2 hybridized carbon. Let us move to sp2 hybridized carbon. Now here the compound containing sp2 CX bond, we will see at those compound. So here you can see that okay, we have a halogen that is attached. Oh, sorry for mentioning wrong picture here. So these pictures are wrong. So I will give you a good picture instead of this. Okay, or you can say good example instead of this. This one are wrong. So what are the vinylic halides? So these are compound in which the halogen is attached or bonded to a sp2 hybridized carbon, which is attached to a sp2 hybridized carbon. So what is this meaning? What is the meaning of this? So I mean here that this is that halogen which is attached to a carbon which is having a double bond, Example, if we take example like this, we attach the X here. Okay, so if we attach the X here, then we will term it as what? We will term it as vinylic halides. So these are the compound in which the halogen atom is bonded to sp2 hybridized carbon of a carbon-carbon double bond. So you can see that this is the carbon-carbon double bond and the halogen is attached to this carbon only. So in this case, you will term it as what? vinylic halides. Now next, again, you will get confused. What is aryl halide? It is similar to that, but in this case, the double bonded carbon is attached, is a part of aromatic ring. So we can have this example, very easy example to imagine. So I'm saying that the carbon-carbon double bond of which we are talking about, which is attached to halogen, is a part of aromatic ring. So this carbon is a part of aromatic ring. So this is a vinyl halide. Okay, this is vinyl halide, and this is aryl halide. So this is only haloarene. So this is haloarene only. So this type of compound in which the halogen is attached to a carbon which is a part of aromatic ring, they are called as haloarene. So this was the classification which is for the sp2 carbon. Now I have not mentioned one slide here, so I will just talk about it very quickly. So in dihalogen compound, we have a further classification. First of all, I mentioned what is dihalogen. What is dihalogen compound? Dihalogen compounds are those which contain two halogen atoms. Okay. Now two cases arise. Suppose we have two carbons, we have ethane system, and we have two halogens, and you are asked to rearrange this X. Now you can put this X in two manners. First, you can put both of the X on one carbon. Second, you can put it on individual carbon. So if you put both of this on one carbon, then we call it as gem. And if you put both of this on different carbon, then we call it as vis. Okay. Now this is called as gem dihalide. And this we term it as vis dihalide. Vis dihalide. This is clear? Okay. Now we are done with the classification of haloalkane and haloarene both. So this is also a very good classification. You should remember this name. So student forget this often. So you should remember this. Gem and visnal. Geminal. This is also termed as geminal. Instead of gem, sometimes you will find it written as geminal, and this can be written as vicinal. So this was all about the classification. Now, if I ask you that, if you ask me that which one is the most important, then I will suggest that remember this thing, that what is primary, secondary, and tertiary. So this you must have seen earlier also. Okay. So when you were studying this organic compound, simple organic, some basic concepts of organic chemistry, you must have used these terminologies. So this is used more often. Okay. So I will make you remember one more time. So in this case, what will happen? The halogen group is attached to one carbon or zero carbon either. In this case, it is attached to 2 carbon, and in this case, it is attached to 3 carbon. Now you can generalize it also. You can, I would say you can generalize every classification. You can extend it to any functional group. So this, instead of primary alkyl halide, this can be also primary alcohol if it is replaced by OH. Similarly, we can have primary amine. Okay, so this is different. This is not amine. This is for OH and haloalkane. It is good. Okay, so we will call it as primary alcohol, secondary alcohol, tertiary alcohol. So this is the most important classification of all of those, but I would not suggest you to just focus on this. Remember, all of those you can be asked by making it a part of a different question, and when you will miss that, you will not be able to solve a more simpler question. Suppose a simple question is asked, you know all of the part, but a single word is deteriorating your marks. So you will feel very painful at that time. So it is important to have an idea, or you can say to remember all of this classification. And I would not assume that this is very tough to remember. So you must remember this classification. Now, with this, I would try to end my lecture. So we will talk about tomorrow. So we will see what is this nomenclature of compound. You must have studied this nomenclature earlier also, but we will make it a quick revision of all. We will look at the complexities of those, and then we will look at the nature of the CX bond. So we have seen CX bond throughout this discussion, that okay, this carbon attached to this X, this carbon attached to this X. So we have seen it throughout the lecture. Now we will try to see what is the effect or what are the reactions this CX bond can undergo. Okay. So with this, I end my lecture here. Thank you.